Here we are.
Yep.
Aha. Well, hello again, stargazers. Welcome aboard the June 2022 first meeting here online. There's a lot going on in space these days, space news and discoveries. It happens to be the very reason we like to convene live on Monday mornings, 11 to noon, for the online vlog podcast known as the SBAU Astro Hour. I'm Baron Ron Heron. Actually, I stopped using the Baron since I'm not on the radio. Just plain old Ron Heron, the VP, using Zoom from our man caves and computer rooms. SBE, that's Santa Barbara's astronomical unit, our South Coast Longtime Telescope and Astrophysics Club. Lots to talk about. This is episode 67 for June 6th through the 12th, 2022. Let's meet the Brain Trust, our beloved 4 years now running president, Jerry Wilson. I'm tempted to call you Dr. Jerry, but you don't like to rub that PhD in our faces. Is it framed and on the wall somewhere in your house?
Yeah, actually, it's right here next to several others. But
all
yeah.
right, someday you might want to hold it up there in front of us. We have Chuck McPartland on the screen with the flag of Ukraine behind him, and he is one of the most outstanding outreach coordinators anybody could hopefully have for their club, and he's probably been with the club more than anybody since way before we had the name SBAU. I
joined when it was AU, and there's several people that are older or longer tenure.
Well, Briley Lynn Lewis is writing an article for some magazine. I think she said it's ASP. Are we members of an ASP?
It's the Astronomical Society of the Pacific. It's kind of an individual membership thing.
And right. Is that the magazine she's writing the story for about? And
they have a couple of magazines, and it sounds like she was doing it for them. Yeah.
Okay. Well, you sent her an incredible history of our club, and I thank you on her behalf. Well, she thanked us too. As Bruce joins us, I'll introduce you to Mr. Tom Whittemore. Tom.
Morning.
I've joined you, but I don't seem to have video showing.
Well, that's all right. You're ugly. We don't want to see that.
That makes 2 of us.
That makes 5 of us on screen, I got to tell you. Tom is our former Westmont connection, a college science instructor, ran the lab out there, editor of our monthly newspaper, our newsletter, which is about to come out. No, wait a minute. It did come out.
Oh, no, it's out. It's out.
Yeah. For June. We also have, I'll tell you my plug.
There you are.
Yes.
There he is. Still recovering. Bruce Murdoch is a longtime active member, president of the Santa Barbara Theater Organ Society. You guys, like us, are trying to get back in the public eye and meeting and convening and still wearing your mask.
Yeah, we have started. We now are holding our open consoles on the second Saturday of the month. Excuse me.
We got to get a whole show in there, whole 2 hours of playing that sucker full blast out of those little Spanish villages on the side of the screen at the Arlington. Gentlemen, here's what we're going to talk about today. We'll try to get to all of this. The Pan-STARRS comet gets a little brighter. It's probably going to go away. It's not near us. We check out our summer triangle. What is that? The summer triangle. Catch a lion by its tail. The Nebula in Leo. Where is Venus? We're going to ask Tom Whittemore about that. He's seeing it. Hercules. It's another star cluster. And I'd like to start right after we do the comics, Mr. President, with this incredible, now a word from our sponsor about our beloved mentor and the people that love us and support us, the Museum of Natural History. You put a little short history with a couple of stunning pictures in the middle of your talking points. But first, silly stuff, silly science cartoons as sent out by President Jerry. Can you call those up now that you're running the program? Grab one and I'll tell them what they're saying. Random Comics was the first one I got. Let's see here. Is this the one today? Random Comics. Okay, the kid asked the old man, when was gravity discovered? Uncle Cosmo answers, very long time ago, son, when a cartoon coyote named Wiley ran off a cliff. Is this the right? Yeah. And hung there in midair for a few seconds until he looked down and a skinny desert bird took off running away. Beep, beep. Okay, that was sent to all of us. You got another one?
Yes, Tom is very well organized. I guess I haven't picked up on that yet.
Okay, well, if you find it, throw it up in between stories and we'll take it as
Okay.
it comes. You sent out one this morning. Did everybody get it? Labeled field trip?
Yep.
The
Yeah.
nerd-like kid well, I'll just tell you what you're going to see. Class, this Friday, there'll be a quiz on Jupiter. The kid in the class says, how are we going to get there, teacher? Okay,
We're getting an Amazon site here, Jerry. Oh,
Oh,
man is learning his craft.
okay, wait a sec.
Very talented gentleman. Runs this club.
there we go.
Ah, okay. Class, this Friday, there'll be a quiz on Jupiter. I thought of that. And the minute I read this, I thought, how are they going to get there? And that's exactly what he said. That's the punchline.
I did too.
Okay, that's cute.
And
You don't have the-
for it.
You have the
Play on
pogo-
words.
Okay. There's one called Discovery of Gravity. Pogo cartoon. Oh, that's the one we're just talking about now. Work it out. The age-old question in the doctor's office. You don't have that one? And the field trip was kind of cute. Oh, that's the one we just did. Skinny desert bird. Okay, we got it. That's enough. I want, with your permission, if you could.
Am I showing one now?
What?
Sure.
We're not seeing anything.
Okay, wait a second.
But we are on YouTube for the benefit of the club members. And we hope to go back into Farron Hall by August 5th, I believe it is.
See one now?
Nope,
Not yet.
Yeah.
I got our 5 ugly mugs on the screen. Here it comes.
Okay.
Ah, there we go.
There we go. All right, let's see.
Yeah.
A pair of archaeologists standing on the edge of an unearthed discovery in a big hole at a construction site. Apparently, the fossilized bones of a T-Rex show its horrific skull holding in its gaping, multi-toothed mouth a crushed alien spacecraft. One says to the other, you know, this complicates things quite a bit. That's crazy. At Random Comics. Hadn't heard of those. The Far Side are the best.
Yes.
Well,
I don't have a fourth one.
Well, you sent out one this morning. Oh, no, that we saw that.
Yeah, I showed that one.
Okay, well then,
I guess I lost one of them.
I would love to go right to, rather than sandwiching something so interesting, local, right in the middle of all us,
Okay.
the heavens, for you to go to, and now a word from our sponsor.
Okay.
Take a look at how our beautiful Santa Barbara Museum of Natural History first look 100 years ago.
Yeah.
That's when the picture was taken that we're about to see here. It was founded in 1917, but our vintage photograph was taken in 1922, right there.
Yes. Now, if you look at the margin of the thing over here on the right, it looks like it says 1926.
Yeah.
But the caption on the website for the museum says 1922, so I quoted that.
Mhm.
So I
Okay,
don't know, someone's got bad handwriting there or something. But this
So
is
this is after the earthquake.
which is 1906.
No,
No.
you said 1926.
Yeah, 23 we had an earthquake.
Oh, it's 25.
Oh, was it? Okay. So anyway, this is the original entrance to the main building, and you see these spiral columns here at the round of the front there.
Mhm.
And that, the reason for this whole thing is.
what is that incredible picture of,
The live microphone.
are we okay? Here it comes.
Yeah.
There they are, ladies and gentlemen, courtesy of the Hoffman Bird Club, taken back in 1931, no less a visitor to our beloved SBMNH than Albert Einstein in the middle with
Al and his wife
That's why.
Elsa.
there, and you see the same spiral columns.
Uh-huh.
at the entrance to our museum. Now, I had seen, the reason this struck me was I had seen this picture. I read a lot of books on the autobiography, or not the autobiography, but biography of Albert Einstein. And this picture crops up a lot of those places. And I know it always had the caption in Santa Barbara, but I never knew where. And after I joined the club up here in the SBAU, I recognized it for the first time, that it was the front end of our beloved museum.
And it's hard to see in those pictures, but above the entranceway, there's an egg with a pair of wings on it in the arch up there. And that's because the building was originally owned by a guy, and I'm sorry, I don't remember his name, but he collected bird eggs.
Yeah.
Right.
And it was the Museum of Oology.
Okay.
Yeah, there it is up at the very top.
But this is today, and the name has changed probably. There is an egg with wings on it up there. And these are the same spiral columns. So Albert Einstein stood right here 89 years ago, 1931 to 1922. So 91 years ago. And after I joined the club, I spotted these things and decided, oh, I've seen that picture before. So I decided to include that this time.
Sure. We're being
That's
brought to you
neat.
by the museum that loves us.
Yeah.
Where we used to have our meetings didn't exist back then. I'm sure there was no Farrand Hall or planetarium,
Yeah, I think a lot of our auditoriums were added in the years since 1917.
like Fleischmann Auditorium.
Yeah.
There was a creek back there, and that is Mission Creek, isn't it?
Yes.
That's right.
Okay. Well, we miss it. We're going to go back, the merry month of August, live if we can.
Hopefully, yes. I noticed in the LA Times over the weekend, they had an article that said that Los Angeles and possibly Southern California may go back into a mask mandate situation because of the slow rise of the current COVID variant.
Yeah.
It's not slow. If you read the paper, they're double-digit infections, and now the latest one, they're triple-digit infections per
Okay.
day.
That's faster than the article implied, yeah. So it's kind of making me nervous about some trips I'd planned. See my son
I think
San
they had
Diego.
275 infections in yesterday's paper.
Well, I had a lady all set up similar to Briley. She's an undergrad about to get her PhD at UCLA for August, but she could not come up here. And I just told her, look, there's a chance we might not open. Therefore, you can do your science talk from your living room. And
Even if we do open, she can still do her science talk from her living room. We can display it on the screen at Farrand Hall.
I was going to ask you about that.
Yes.
Because you had alluded to the possibility we could broadcast. Is that a good word? We could actually send out our meeting through cameras. I've never seen cameras set up like a studio in there, but perhaps.
I don't think that we need cameras. I think if we have it in the computer system to display on the museum hall or the Farrand Hall screen, then we can also send it out on Zoom.
Okay, that big screen that pulls down behind the.
So we'll leave that to our ever surprising webmaster who can do all sorts of magic with these circuits.
Who was that? I forgot who he is.
Oh, it was some guy named Tom.
Oh yeah, there's another Tom. And on July 1st, our science speaker is provided by JPL. He's a NASA scientist named Dr. Robert Zellum, who's going to specialize in talking about life possibilities on exoplanets.
Oh,
Your talking points, things to come, the summer triangle, another asterism. I'm finding there's all kinds of asterisms. Soon be posted overhead on warm summer nights. But first, just before we hit summer solstice in a few weeks, one of springtime's star patterns, the Great Diamond, known also as the Spring Diamond, also called the Diamond of Virgo or the Virgin's Diamond.
Although right now we're looking at the summer triangle.
right.
Okay. Is the diamond in there somewhere?
No.
Not yet. Soon.
Oh, okay. Well,
So from Vega, which is a first magnitude, well, I think it's a first magnitude, a zero magnitude, first
It's
magnitude.
a zero. It's the definition of zero magnitude.
That's right. And then Deneb and Altair Altair is always distinctive to me by its two satellite stars there. They're not true satellites, but just a simple little 3-star asterism. And this will be high in the sky over our head in summer. Looking forward to it. There's Cygnus the swan with its long neck here and its short tail. If this were the head, then this would be Cygnus the hawk. But it's not. It's Cygnus the swan with a long neck. And Vega, the little trapezoid up here, and right in the lower part of the leg, right down here is where M57 is. So it's an easy find with your finder scope.
Yeah, the Ring Nebula.
Yeah, the Ring Nebula. And then, of course, you have a very nice picture of the North American Nebula over here with Pelican Nebula. And
Albireo.
Yeah.
yes, I was looking to see if I can see, yes, there's the Veil Nebula there and there. I think that's the Veil Nebula on this side. I see a little arc right there. And that would be 51 Cygni.
60,
52?
I thought 61. What is it, Chuck?
661
51, I
is
thought.
Piazzi's flying star.
Yeah. Oh, so
I
it's
think it's
50,
52 in
52
the ring,
Cygni. Yeah.
Okay.
or in the Veil.
Mhm.
Yeah.
So the asterism is simply those 3 bright stars making a triangle?
Yeah,
Yeah.
makes a very easy triangle. Looks up, you can see it real easy first, and then it orients you where to look for all the other constellation parts.
Was that the Milky Way behind it?
Oh,
Yeah,
yeah.
very nice picture of it. See the dark nebula clouds in front of it that are not illuminated and do not glow. So it looks like missing stars, but it's actually not. It's just dense lanes of dust.
Mhm. Yeah, it's often called the rift.
Yeah, the Great Rift.
Great
Mhm.
Rift. Well, you put magnitude 0 on Vega. Does that mean that's the brightest? There's even brighter, and they go into minus numbers, don't they?
Yep.
Yes.
Right.
Yeah,
Like Venus.
But they had to
Yeah.
define the scale, and so they chose Vega to be the
The
zero.
midpoint or the median.
that was
whatever.
one of the great arbitrary choices of science. The other one being the current is what the flow is in the direction of positive charge flow, when actually they found out later it's electrons and therefore the negative charge that flows. So
Well, the higher the number goes above 0, the dimmer it is. Where do they
that's
stop?
correct.
When do
They
we
don't
not?
stop anywhere. It's an open-ended scale.
So,
And
It's
Jerry,
also
just-
a logarithmic scale, but it's got a factor of 2.5,
Yeah, every 2 numbers.
Right.
which is screwy.
Oh, no.
Well, it was an attempt to. It's sort of an attempt to mimic the eye's response because it comes from an old Greek manuscript that said stars of the first magnitude, stars of the second magnitude. It's one of those legacy things.
Yeah.
I want to point out, Jerry, it's a really beautiful shot. You can see the dolphin jumping out underneath the triangle. Delphinus the dolphin,
Yeah, the tiny.
right there. Mhm.
And that's like a Shumash story that we tell in the planetarium, where the arc of the Milky Way there is the Rainbow Bridge coming from the islands to the mainland, and the goddess Hutash was out there. The Shumash were living on the islands, and it started to get crowded, and they were noisy, and they started to quibble with each other, and so Hutash built this Rainbow Bridge to the mainland and said, you can go across to the mainland if you want, but don't look down. And of course, some of the Shumash going across the bridge looked down and they fell into the water, but Hutash didn't want them to die, so she turned them into dolphins. And that's the story why there are dolphins out in the channel.
It's really neat. It's a neat story.
now, is that an asterism or is it a full constellation?
It's a constellation, Delphinus.
Mhm.
Delphinus, the dolphin. Never called porpoise. That's all right.
Okay.
Can we get to the Great Diamond from here, or you did have most of it in that opening story?
Yeah, let me find the spring diamond.
All right. Great Diamond, Spring Diamond, Diamond of Virgo, Virgin's Diamond. Diamonds are a girl's best friend.
Okay, there's the spring diamond,
Okay.
Arcturus, Cor Caroli, Denebula, more about that later, and Spica.
The ace of diamonds.
So this is what's overhead right now, and we're coming out of the Coma Berenices, Virgo galaxy cluster areas. That's a springtime event, March and April and May. Now we're getting into the summer.
And this is not as obvious as the summer triangle, but
No. Especially with core corollae that doesn't stand out like the other ones do.
Right, right.
So,
and that photo that was there of core corollae doesn't look right to me because I don't see color in core corollae. It looks like two very white stars, and yet in that picture it looks almost like an alberio type.
let me get to that.
Photoshop.
Photoshop. Maybe it was Photoshop, but let's see. Nebula.
Is the Nebula the same as Deneb?
No.
No,
No.
I mean, it's a little tail.
Oh,
This is not a star related to the Nebula.
oh, well, it's in
Yeah.
my notes. I got it here in my notes. It's one of the four.
Oh, well, the time triangle too, but we're looking way closer now. You can't see any of the other parts of the triangle.
Mhm.
This are the triangle of the diamond.
Yeah, Ron, Deneb is an Arabic word for tail. So there's Denebola, tail of the lion. There's Deneb, the tail of Cygnus the swan. There's Deneb Algeti, the tail of the Capricornus. So you'll see Deneb all over the place.
Mhm.
But the Nebula is one of the four stars of the diamond. We just
Yes,
saw.
it's the tail of the
Yeah.
lion.
Okay,
The
tail of the
brighter one. But let's look at core corollae here.
Huh.
That's cool because it's not a photo, it's a drawing.
Mhm.
magnitude 2.9.
Let's see. Oh, what did I label it? See, that's the problem. I'm my own worst enemy. Alpha Centauri. No, geez.
Must be part of the genus Homo sapiens.
There it is. Under drawing.
Core corollae is a binary.
It is a binary.
Ah,
A good colorful pair of binaries, and this is from a drawing, a sketch made by Jeremy Perez.
Yeah, see,
Oh.
I don't think it's that colorful myself from looking
Well, he
at
might
it.
have been interpreting it and emphasizing it.
a pair of binaries, therefore it's four stars.
No.
No, it's just, you see the two. It's pretty easy
Oh.
to split, Ron, with the
Right.
small scope.
Well, are they in the middle? Why is there a circle around it?
He's just drawing the limits of his eyepiece field of view.
Oh,
He
okay.
took this with a 6-inch f8 Newtonian, and he's looking through a 10 millimeter Plossl eyepiece made by
Okay.
Sirius and a 2x Barlow, so a total of 240 power and a 12-minute field of view.
Okay.
Ah. Therefore, they're both core corollae.
Yeah.
The two of them together,
Yeah,
yeah. Orange and blue and orange. What colors do those mix together to make?
Well, really, they both look pretty white. I think this is
Very intuitive.
this is off.
Okay.
Well, it's got to take a few years for them to get around each other, I would imagine, in their orbits.
I know my wife sees all stars as white. And I showed her one time Antares under high magnification telescope, and she said that might have a little off-white color.
Mm.
Okay,
But
Tim
that's-
Crawford just texted me and he says that he sees color, so
Yeah.
must just
okay.
be my eyes.
The one lower right is a little yellower.
Yeah. But remember, drawings are an interpretation of the vision of the person doing the drawing.
If they're exoplanets, you think they're going around both of them or each of them?
That probably around, those are quite wide apart to show up in a 12-minute field of view. So I would guess that if they have planets, they're probably, and they're anywhere near the Goldilocks zone, they're probably around each star individually.
Fantastic.
Okay, what next?
But these stars could be like Alberio, which look close to us, but they're really, I think, about 200 and some odd light years apart. It's just because one is considerably further away than the other in the way we see, and they look close together.
Yeah, and that's the case here too. To be separated in a 12-minute field of view is they're quite far apart at that distance.
Well, when I learned from you guys that more than half the stars in the sky are binaries, I went looking for the doubles and I couldn't see one.
A lot of them are so tight there spectroscopically that nobody has seen the two stars or multiple stars. You can just tell because the spectral lines split.
They're really close then.
Yeah.
You want to go check on the comet, the Pan stars, good old Comet C/2017 K2. The big capital letter K2 is, I guess, a short way of calling about it. It's now in Ophiuchus, the 13th sign of the zodiac that gets very little respect. This month, currently magnitude 9.6.
Yeah.
From the Comet Observation Database saying it's getting brighter, should peak at magnitude -7? No, just 7.
Now, it's never going to get really close to us. It's out past the orbit of Mars at its closest. But it will get up to magnitude, I think, what did you say it was, 7? Almost invisible?
Yeah, right.
Okay. So this is where it shows where it was last night, I think. Yeah. Well, I guess I didn't put down the time, but it was from the ephemeris for a few days ago. But it won't be significantly different here at the intersection of the red crosshairs up from Altair, Ophiuchus. I like to mention that Ophiuchus is the 13th sign of the zodiac because astrology doesn't recognize that. So
where is the month for it? That's the part I can't understand.
It's December.
Yeah, Chuck is an Ophiuchus sign.
Yeah.
The sun spends more time in December in Ophiuchus than it does in Scorpius.
Chris Christopherson once had a song called Jesus Was a Capricorn, but maybe he was Ophiuchi or whatever. Incidentally, this comet is 25 miles across, about 4 times the size of Halley's, and will not get close to us. In fact, is it going to get any closer than the orbit of Mars to the sun?
No.
In the world.
Now, K2 is obviously its short name, and it reminds me of another K2. That is that back in the turn of the 19th and 20th centuries, when they were trying to estimate which was the tallest mountain in the world, they went up to several mountains back then, and they tried to sight with theodolites to other mountains and decide which was higher or not. And they pretty much had correctly labeled Mount Everest, but they did not get the second highest mountain correctly. It was too remote. And so then when airplanes came in and they were able to take stereo photos, so they were able to determine the heights of these mountains, they found that one that had not even been named, it was so obscure, was the second highest peak. And so they just went with its map coordinates, K2. And so that's the second highest mountain in the Himalayas.
Not far from Everest, but I thought it had a name that started with K.
No, it's just K2. It's the map coordinates.
All right, so this Pan stars has a very wide oblong, not very close to the sun. You'd think that out that far you wouldn't get enough summer or sunshine, the streaming particles to make a tail, would you?
Well, this stuff, the volatiles on these things are very, very volatile. Pluto is covered with flows of solid nitrogen and other cryogenic solids. But Jupiter has a slightly elliptical orbit. And the belief is that when Pluto is closer to the sun, a lot of that surface ices melt and sublime and form an atmosphere. And the atmosphere can be picked up by telescopes. But when it's far away from the sun, that stuff refreezes back out, and Pluto doesn't have a significant atmosphere. So this stuff is very sensitive to even at low amounts of heat.
Wow. That sounds like a topic for a future show. We ought to put that in your talking points in a week to come. You want to go to another open star cluster? I'm learning all about star clusters, and there's all kinds of types. This is NGC 6633 at magnitude 4.6, which I imagine means it's seeable with the naked eye, nearly the size of our full moon. And this star cluster contains only 30 stars.
Oh, yeah, I didn't put a photograph of that one in.
Oh, okay. 8 degrees east of another cluster, magnitude 4 IC. What does IC stand for? IC 4665?
Index catalog.
Why haven't I seen that before? One of the brightest in the galaxy.
Oh, it's come up a few times, but we don't mention it so much. There's so many catalogs.
You had an interesting picture of Venus over a lake in New Zealand, Mr. President, and we'd like to get maybe Tom Whittemore's take on where our brightest star, which is actually a planet, is. It's a morning star, right, Tom?
Yeah, right now, I mean, if you have a good horizon without any hills, you can catch Venus pretty easily before the sun comes up. I saw it this morning at between 5 and 5:15. Very, 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 very bright.
Now, this was published by a magazine, Astronomy Magazine, and you can see down here the zodiacal light.
Oh,
And then there's Venus at the top of it.
Mm-hmm.
and that's Lake Pukaka or Pukaki or
Whatever I wrote in there,
Yeah,
I
it's
seem to recall that,
Pukaki.
in the North Island.
Yeah.
I heard Neil deGrasse Tyson say the other day that if you make a wish on Venus, it's not a star, so you won't get your wish come true.
No, I'd fall back on the technicality that it's referred to as the morning or the evening star.
Right, right.
and
That
they
was-
used to think it
that
was two different objects, and they called it, I think, Hesperus and Vesperus or something like that.
Yeah, something, yeah.
Well, was it Galileo that determined it was a planet?
No,
No, it moved, so they knew that it was a wanderer.
Mm-hmm.
Okay, but they didn't know it was a planet. Who discovered it
well,
as
planet means wanderer. They knew it was a
Wanderer.
planet since ancient times, but they thought it was two different planets.
Right, but they didn't know exactly what a planet was.
they thought it was two different, like a binary? Is that what you're saying?
No, they thought it was a morning planet and an evening planet.
And it just showed up sometimes.
Oh, two separate ones.
Yeah, they didn't know about orbits so much. They
So,
had
yeah, Ron-
discovered
Ron-
cycloids.
Ron, there were five wanderers that people just took track of, and planetos in Greek does mean a wanderer, like these guys said.
And actually there were 7 because they included the
Yeah.
sun and the moon.
The sun and the moon, too.
And that's where we get our weekdays. They're named after them.
Yeah.
Well, now, obviously, they didn't have photography back then, so either a great memory of the sky the night before, or they put dots on paper or chiseled holes in rocks. How did they monitor the fact that all these other stars stayed the same, but this one wanders? Do we
Well,
know?
you can see it, obviously.
Yeah.
Just
No,
know.
they did drawings.
Yeah.
Yeah, drawings, paintings, they did architecture to follow it, all sorts of things.
Yeah.
And they could do measurements relative to other stars.
Yeah.
Okay.
I just want to go back for 1 second. I was going to mention this when you guys were talking about K2, the mountain in the Himalayas. They put a monitor on that thing where you can actually read the fact that K2 is rising very, very, very slightly, okay, year by year by year because of tectonic activity. So a plate is basically pushing up that landmass called a mountain. You can actually measure it. And I think K2 was one of the ones that they actually have been tracking. It's not much. It's just, maybe pieces of a millimeter for every year, but you can measure it. So it is rising.
So
I'm
plate
not going
tectonics,
to say that K2 will ever overwhelm Everest, but, it does rise.
yeah.
Me too. It's permanently, we're not going to use pan stars. Chuck, you said some planets were lined up, interestingly.
Yeah.
Yeah, in the morning sky for the next couple of weeks,
Mm-hmm.
we have all the naked eye visible planets are lined up, and it's interesting because they're lined up in order of their distance from the sun. So
Right.
Mercury, Venus, Mars, Jupiter, and Saturn.
Right.
And they're over quite a wide range of sky, and Mercury is pretty hard for us to get because of our eastern horizons with the mountains and stuff, and it's still pretty low. It's going to get higher in the next couple of days. But it's just an interesting alignment that happens on the order of every 50 to 100 years.
Right. And I remember when we still lived up in the Bay Area, I went up into the mountains above Stanford because the planets after the sunset were visible, these 5 visible planets to the naked eye, and they were in order. So I saw that. And then they flipped around the sun and they were in order again. But it is, like Chuck said, it's a pretty rare thing to happen to have them in order. Chuck, do you remember seeing that? It was about maybe, 2000, 2001.
Like in May?
Yeah. So we could see them in the Bay Area pretty easily because we got to the top of the mountains behind Stanford to see that.
Not being a morning person, I remember seeing the evening version of that.
Yes. No, that's the one I'm referring to. And a friend of mine I went to high school with, who became basically a phenomenal astrophysicist, had never seen Mercury in his life before, and so he got a chance for the first time to see Mercury. And Mercury, of course, was the lowest planet of the bunch.
And the rumor is that Copernicus never saw it.
Yeah.
Now, when you say they're lined up, Chuck, does that mean left to right in the sky?
Yeah, or from the sun outward.
Yeah, left to right now in the morning. I didn't get a chance to see Mercury. Still pretty close to the sun, and it's getting blotted out by the glow. But Venus was just real obvious and really, really, really pretty.
And Jupiter will also be real obvious.
Yes.
Did you find the version of that on screen, Mr. President?
That's what's up right now.
This is a planetarium show, and you can see this is for June 7 at 11 p.m.
Okay.
Wait a minute, 11 p.m. where?
Yeah, it should be here, but it should be in the morning for us.
Yeah.
Huh.
Well, yeah, so it might be looking through the Earth. I have to watch for that. This is Mercury, Venus, Mars, Jupiter. Where is Saturn? Oh, there's Saturn.
Way to the right.
Yeah.
Yeah, you can see how much Mars has moved away from Jupiter in the last couple of weeks. They were basically sitting on top of one another about 2 weeks ago. Mars was lower than Jupiter.
And Jupiter was near Neptune a while back, so
Yeah.
So you can see them wandering.
Mm-hmm.
Wandering stars.
Hey, Tom,
Yeah,
I'm getting a text.
This is the sun over here.
I'm getting text from Tim wanting to hear about star testing in the daytime.
Oh, okay. May I pop that in right now? Because maybe, maybe Jerry, maybe you've done this yourself. I learned this technique. So how do you star test a telescope in the daytime? Because you don't have, a night sky for the contrast. And so what do? So I learned this technique from Bob Fees. Okay. And thank you, Tim, for mentioning this. I learned this technique from Bob Fees, who is the guy who is coding all of our mirrors. He used to code all the mirrors for John Dobson's students. Okay. Bob lives up in kind of the North Peninsula. Not Redwood City, but up in that area. Anyway, what he did was he had this huge, tall pine tree, and he hung a Christmas ornament from it. Okay. And during the daytime, of course, the Christmas ornament will reflect a little dot of the sun, and you can actually use that on a steady afternoon to fake it for a star for your star test. Okay. One of the things that you have to have happen if you're going to do this kind of a test with precision is you have to have the star, quote, in quotes, at least 20 focal lengths away from your mirror. Okay. And so, for example, if you have a mirror with a focal length of, let's say 5 feet, which is kind of typical for a backyard telescope, then you'd have to have this little ornament about 100 feet away. Okay. And what it does is just minimizes the errors, okay, in the area ring reads. So you make, like every star test, what you end up doing is you read the area rings. And so you go extra focally inside of focus, look at the area rings, and then you go outside of focus.
Yeah, you're approximating a point source.
Exactly, Jerry. And it actually works darn well. The thing that John Dobson used to advertise was insulators on telephone poles. Those things a dying breed. So you don't have them anymore.
Collect them, so they're disappearing all over the place.
Yeah. So the Christmas ornament, and I recommended to Tim, because he wanted to do this at his house, to use maybe a silver globe. Okay. To
or
make
a chrome bumper on a car.
That'll do it too.
If you can
Here's
find
What I
one of
use
those.
is what I use is I have a piece of flat black, flat black cardboard with a tiny hole in the middle, and I've got aluminum foil on the back of that. And then I can mount that on my tripod and angle it so that it's actually reflecting the sun from that little tiny dot.
We did that in the basement of the Griffith Observatory back about late 50s, early 60s, when I was learning how to make mirrors. And we used a small ball bearing, polished ball bearing that was set. We had an optical bench that went back through a utility tunnel that was made out of beams of teak wood that were off of the deck of a battleship. Wow. In that time, there was a lot of surplus equipment coming out of all sorts of the places as they were decommissioning ships and stuff. So we had a very nice optical bench that went back tens of feet into the utility pole, and it had little rollers and a pulley system that you could put something there, and then you could move it way out.
Wow.
And so we had a ball bearing that we set, and you moved your mirror out on it, but you had a ball bearing set next to you and a line and a light shining on it, and the ball bearing was in a negative mirror that would make it look very far away, and that's how we made an artificial star.
There's also a little electronic artificial star made by a company called Astro that you can get. Powered by a 9-volt battery. It's got a very tiny pinprick hole and a very powerful white LED. And so you turn it on and put it 100 feet away, 200 feet away on a tripod, and you can use it.
Yeah, back in that day, just as an aside, we didn't have LEDs. Yeah. We had light bulbs that were like 20-watt bulbs, and we put them inside a copper cylinder, and there'd be a little prism on the side of it, in a pinhole. So the light would come out, reflect off the prism, and go down the optical bench. And with the prism right next to your head, sometimes I'd burn the side of my head because the copper got real hot when I was testing mirrors.
Well, gentlemen, any one of these topics would be a great backup if I didn't get a no-show on our science speaker. If you guys don't mind, we'll continue that in front of the membership. I've learned a lot. I wanted to ask Bruce real quick before we get to one of our other topics, if you were going to be able to make it to Star Party this Saturday night at the museum.
Probably not.
Well, are you getting around in a wheelchair?
No, I'm walking around. I can't sit up for a long period of time. Okay. My back starts to hurt.
And you,
I'm most comfortable in this zero gravity chair that I'm in right now.
Zero gravity? What does that mean?
Oh, it tilts all different ways, so I can lean way back.
All right.
Just a brand name.
It was our last Star Party. You injured yourself, right, at the last one in the dark?
Say again?
That was at the Girl Scout event, Ron. That was a while ago.
Up at Lake Kachuma.
That was about 6 weeks ago.
Oh, has it been 6 weeks? Man, you really hurt yourself.
Well, it was the end of April.
Okay. Well, you're recovering there, my friend. You're the president of a organ society and one of our stalwart members. We can't do without. There were several stories that I'd like to get to. Edwin Hubble coming up with a Hubble Constant back in 1927 or 23, Mount Wilson, using a Cepheid variable in Andromeda. If you can find that, this is something of history that I've actually managed to maintain. Observing, he found a variable star, not in our galaxy, but in Andromeda, which is what, 2.5 million light years away? M31, allowing him to calculate its distance, proving it wasn't in the Milky Way and it was a Cepheid variable. So
he got the wrong distance because he didn't take into account dust and gas in our galaxy. Yeah. But yeah,
right. But he got a distance that was so wild, though, that it clearly indicated it was outside our galaxy.
And this is almost to scale. This is the 4-inch by 6-inch plate glass picture.
Slide, yeah, negative. He's indicated a number of stars that he can see in the Andromeda galaxy. He can resolve them. This one up here, he realized this was through repeated observation, this was a variable. And not only was it a variable, it was a Cepheid variable. And he relied on the work of Henrietta Swan Leavitt from 1912, who had calculated Cepheid variables frequency to luminosity ratio. So once he had the frequency of that star's pulsations, he then knew how bright it was at the source. And he knew how bright it appeared to him in the telescope. And so that's a simple calculation, 1 over r squared, to figure out how far away it was.
And you can see again, Jerry, in the notations on the edge of the negative that it's October of 23 up there in the upper left corner.
Yeah. Upper left corner. It looks, it's out, it's not well focused for me. I've gone.
Okay, it's also reversed.
Yeah, that too.
Oh, yeah.
I'll take your word for it.
12,
Well,
2,
you can see
20.
also he wrote 6 October 1923 on the main part of the negative too.
Oh yeah, that too, yeah. That's pretty creepy though, hiding in plain sight. I'll never spot that.
But the variable, that's the VAR in the upper right corner, right?
Yeah, you can see he crossed out where he thought it was a nova.
Yeah. And then he said variable.
Okay, so let me see if I understand what you said that he came up with. If that star, that Cepheid variable, were in our galaxy, it would have the same period of luminous fluctuation, but it'd be much brighter, right?
That's
Right.
correct, yes.
Yes, yes. Mhm.
And because it wasn't that bright, it had to be very distant.
That's
Very
right.
And that's how we got the Hubble constant.
Exactamundo.
Well, that's how he got the distance to the galaxy, and it was an external galaxy.
Yeah,
The Hubble constant came from spectral stuff that he and Vesto Slipher were doing.
Oh, you mean going apart, everything
Yeah.
receding from us. Well, the lady that Jerry mentioned, Henrietta Swan Leavitt, has her name on the law. It's called the period luminosity relationship.
yeah.
And we knew this in 1912. It's Einstein's time. What are we looking at?
I think they've renamed that, Ron, as Leavitt's Law, if I'm right.
Yeah.
Is that right, Chuck?
Yeah.
It's now called Leavitt's Law, so they really give an honor to the woman who really did all the back-breaking stuff in the early 1900s. Yeah.
And this is a diagram of Cepheus the King, and it's showing your classic Cepheid variable, which I believe is delta down there in the lower left.
Yeah,
Mm-hmm.
that was the first one. That was the Cepheid that started it all.
Yeah. What's the difference again between Cepheid variables and regular, the other type of variable stars?
There's all kinds of variables, Ron.
Ron, there's tons of different kinds.
But
These happen to be fairly long period, maybe a couple of months to go up and down. And
You gave a great talk about it one night years ago for us, Tom.
oh, thank you. Again, I study short period variable stars, stars that might pulsate, even though they're related to Cepheids because they're typically these yellow giants. The stars I was looking at might vary in brightness over a little bit, okay, of a magnitude over the course of a few hours, okay, but easily measurable in the 24-inch at Westmont, easily measurable with a camera, okay.
Have any of you gentlemen heard recently that they discovered the farthest star 13 billion light years?
Yeah, that's a new news item. That's pretty cool. Jerry?
How in the world do they see a star? I mean, even the galaxy is nothing but blurs.
I have questions about that. I just read headlines and a summary, so I can't explain how they did it.
Yeah.
I haven't
They
included
looked at
it.
the spectral character.
Yeah. I haven't included it because I haven't read the article in depth.
Yeah, they looked at the spectral characteristics of it. They could tell it was an individual star.
Okay. Makes sense.
What do we got here? What are we talking about?
I think Chuck's going to show us the Cat Nebula shortly.
Yeah, the Cat Nebula is right here. Keeps getting filtered out.
That's more of a Barnard type dark nebula.
Yeah.
Say again? What
That's
did you
more
say?
of a, Barnard type.
Barnard, I don't have that in my notes.
No, we're
Ron,
just
we're just
chatting
making a
off-
joke here.
Yeah.
Oh, I see. Okay. But they have zeroed in on a star, and I think it's Antares, isn't it? Astronomers,
Yes.
Chile and Germany, red supergiant, even mapping the velocities of stuff in Antares' atmosphere.
Yeah.
Okay. Unexpected turbulence, unlike our sun.
Yeah. Antares is a very large red giant star. So it gives a disk that we can actually have a hope of seeing, like Betelgeuse.
And that disk was actually measured back in like 1917 from Mount Wilson.
Yeah. I'm using an interferometer on the top of the telescope. Here they've made an interferometer out of 4 telescopes in Chile.
Wow.
At European Southern Observatory's very large telescope interferometer, and the AMBER instrument. I forget what AMBER stands for, but it's in the dot. It's in there. And that coordinates it all together and does the data reduction to get the information they're looking for.
And they also have a couple of small outlier telescopes there too, those other little spots.
Yes.
Are the white lines the actual optical path of the?
Yeah. Yes, they were.
Because they've got a room that's a beam stretcher too, or they because they got everything. They have to get everything aligned in phase.
Yes. Oops, what did I do with that? Do you see that? Your screen sharing is paused. Stop.
It's just a blob.
Yeah, start it again. Okay, there we are. Yes,
There
key
you
thing doing the interferometry is getting the timing of these things on these different path lengths.
Yeah.
So, but it was done optically on the Hooker telescope, the 100-inch for Betelgeuse, but here it's done electronically.
Mm-hmm.
So, and these are the lines of looking at the same star through an interferometer with the observation part right there.
The radio telescopes,
No, these are optical telescopes.
and they're tuned that close. They don't overlap or blur or
No, they actually constitute a larger telescope of aperture equal to the largest distance between the telescopes.
wow.
The 2 farthest ones, it has the resolution of that size of a mirror.
It's
So
a lot
let's
harder to
see.
do optically than it is in radio.
Oh, yeah.
Yeah.
That's what I was going to ask. Is this done in the optical? Because that's really hard.
Well, I know what ESA is. That's European Space Agency. What is ESO?
European
Space
Southern
is-
Observatory.
Southern Observatory.
Oh,
Right. Now, this is the velocity map of the surface of Antares. What you're looking at is a complicated false color look at the Doppler shift of everything. Red is moving away from us. Blue is moving toward us. It's quite a turbulent surface. Stronger
So
motion.
the
of
black
course,
is
than
the black is the outline of the star.
Yeah, black is the outline of the star. This is atmosphere above the star.
And it's
It
kind of an
shows-
arbitrary designation.
Yeah, yes. To be sure, it's not an actual, you might say, photograph. But let's see, getting the next.
if those are taken by Earth-based telescopes, imagine what the Webb's going to show us.
Yeah,
Antares might be a little too bright for Webb to look at.
Oh, that's right. It looks at red.
You don't think they might have filters they can slip in?
Well, maybe.
so this is the actual picture of the star itself, the photosphere of the star. It's not perfectly round, so it's got some bulging here and there due to atmosphere being up. Couple of really bright hot spots here, and then dark. So there's a lot of turbulence on the surface like this. Now this would be about the size of Mars' orbit or Jupiter's orbit in the Earth if the sun were that big, which is very much bigger than the sun.
It's about 1 billion times our sun in volume.
Yeah,
Kidding. Jeez.
But it's only like 20 times the mass, right?
Or
12
even
times
12
the solar
times the
mass.
mass, yeah.
Say again.
Or even
12
just 12 times the mass, but it's pretty
Okay.
fluffy, obviously.
Yeah.
Is it going to supernova?
Yeah.
You could probably
Yeah.
fly through the outer reaches of the atmosphere and your instrument would survive it.
Now, if a planet were transiting that, would we see that dot on the screen?
Probably
Yep.
not. The planet would be very small.
Oh, okay.
But instrumentation could probably see it.
Yes.
But if you've got a really active surface like that, it makes it a lot tougher.
Yeah.
That's Antares.
Yeah. Hey, Ron.
Yes.
So I mentioned that Antares also has a companion star. It's really, really, really hard to catch. But on a very, very good night in San Jose at an observatory I used to play out in San Jose, a friend loaned us his 7-inch f9 refractor, and we got the little star. We got the companion in it. That's the only time I've ever seen a companion star.
That sounds like an astrophysics.
I think it was, Chuck.
Okay.
It was
yeah.
a doublet. It was an AP doublet. Yeah. Yeah.
Maybe.
7-inch f9 ring a bell?
Yeah.
Yeah. that's it.
Both astrophysics and Mead both made 6-inch f9s and 7-inch f9s.
Okay.
And the guy that heads astrophysics, Roland
Kristen.
Christian, Roland Christian, he made the comment that even Mead gets it right sometimes. They're all excellent scopes.
Yeah.
I have a 6-inch f9 Mead.
Yeah. So we were building an observatory at Evergreen Valley College where I used to teach. And a friend named Rich Newshafer, I used to do observing with him, loaned us his AP F9. And we put it on a super mount and everything. And we got it. We got it one night, which is tough to do in the night sky of San Jose. You know?
Yeah.
I've heard that an O3 filter helps on it too, makes it easier to
Yeah,
see.
we probably did something like that, Chuck. It was so long ago, though. It's before we moved down here, Maureen and I.
Well, as far as Antares goes, I'm going to quote Jerry Wilson's talking points here. Apparently, a statement they released says a new, currently unknown process going to be needed to explain these movements in the extended atmospheres of red supergiants like Antares.
Wow.
Something's going on there.
Yeah, normal magnetohydrodynamic turbulence does not account for all this motion and change of shape. So let me also say on the companion of Antares, I've not seen it. I've looked for it a couple times in a SIG F8 Newt, but it was advertised to me as the only green star in the sky. And then later I read that it was only green because of it fools the visual
Yeah.
eye to see it because the other one is so red.
So darn red, yeah, yeah.
Because there are apparently no green stars, even though our eye is most sensitive to green.
Green would be blue
Well,
and yellow.
and that's really an artifact of how we process visual information, because
Right.
our sun actually is in a yellow-green for its
Right.
main output. And, yeah,
545 nanometers.
yeah,
But it defines white for us.
yeah.
Mm-hmm.
Well, I had one question I was going to ask. Something I saw recently on a stupid YouTube video said the sun, every 11 years with the sunspot cycle, reverses polarity and north becomes south. Is that true?
Yes.
Yes.
Mm-hmm.
Does?
Yeah. So you can say the honest cycle run is 22 years if you want.
Yeah.
Okay. But geez, and they're looking at it happening here on Earth, and it's supposed to be catastrophic.
Well,
Those are completely different effects.
Yeah.
yeah.
Right.
Okay. That's amazing, as big as the sun is. We don't have to talk about the big tidal event, the tiny indicator in neutrino indicating a black hole sucked up a star. We don't have time. That was fascinating. Maybe I'll keep that around for next week, Mr. President.
Yeah, we can do that. I'll show that again, and I'll discuss next week. I'll write up the solar cycle and why the sunspot polarity shifts.
Okay, I'd love to find out about that.
Good graphics on that.
Okay, we also missed Open Star Cluster NGC 6633. That's part of the Pan-STARRS comet thing. Saturday, we're going to meet at the museum for our meeting first, and then that's in the afternoon outside the little observatory, and then we have another star party with hundreds of folks coming. And
Well,
wonder how many City College students we're getting. They're going to be graduating soon, aren't they? Before this
they
week?
may have already.
Oh,
We do have Telescope Tuesday this Tuesday night, and then Refugio on Friday night, and then the museum star party second Saturday, then Refugio State Beach again on Wednesday the 15th, Westmont on the 17th, third Friday of every month, then on the 18th, Saturday, Carpinteria State Beach, and then on the Thursday the 23rd, Refugio State Beach again, and on the 25th, Saturday, Carpinteria State Beach again. So that's the outreach for this month.
fantastic. And then I'll see you gentlemen around your fireplaces next Monday morning. Bruce, you're going to tell us anything happening at the Arlington involving the big Oregon sometime?
Well, as I said, we started our open consoles again, typically the second Saturday of the month from 9 until 11.
Give me a website.
SBTOS.org.
SBTOS.
Santa Barbara Theater Organ Society, our initials. SBTOS.org.
All right, my friends, thank you very much for making an incredible hour, and we will get together again in a week. Mr. President, take care of Pat. You too, the merchandise manager, and we'll see you next Monday at 11 a.m. Tom, keep making bread.